Fish worldwide is now gaining better access in the diet over red meat owing to its nutritional value, especially omega fatty acids and its high protein content. In Kenya, the price of commonly consumed fish is lower than that of beef. Fish consumption is therefore favored in the wake of economic hardships. Communities along the major water bodies in Kenya depend on fish and fish trading, which is not an easy business. Spoilage and low market prices are some of the difficulties they have to put up with. Currently, about 13,000 fishermen are directly engaged in fish production along the Kenyan coast. Fish preservation in Kenya is evolving with improvements made on techniques for maintaining freshness. Traditionally cured fish in the form of smoked, sun-dried or salted products were heavily marketed in remote rural areas, which were far from major fisheries and distribution routes for fresh fish. This is however changing with the increase in the demand for cured fish in the major urban areas. At the Kenyan coast, one of the leading fish landing areas is Shimoni and Vanga in Kwale County. The sardines in Vanga are mainly landed in Jasini and more recently, Jimbo. Fish that travel in shoals like sardines pose a challenge during processing, as they appear once in large numbers and if not processed, quickly lose quality and go to waste. The fish are processed by drying, either by broadcasting on the sandy beaches because of the quantities and supposed faster drying rates on the sand, or boiling in water, then drying on sands or mats laid on the ground. The drying on sand is to combat the occasional high landings. Drying fish in the sand compromises eating quality because of bird droppings, which may have disease and majorly sand particles that are to be found in the fish. With a lower eating quality, the market circulation is low, hence prices fetched are low. This leads to those participating in the fishery to continue living in the poverty cycle. Proper methods of curing will therefore play an important role in converting the fresh perishable fish into relatively shelf-stable products that enjoy high demand. Milkfish, a farmed fish, is also sun-dried and sold to rural communities despite it being in non-standardized and often poor hygienic conditions. The traditional sun-drying process is generally slow, taking about 8 hours per batch. Sun-drying is also weather-dependent and particularly difficult during the rainy season. There have been previous intervention on milkfish preservation by provision of freezers, though such are only used in locations with electricity power supply.
Sasa hapa solar cooling and drying technology tunatumia nguvu ya jua. Nguvu ya jua kukausha na pia kutengeneza barafu. Sasa hapa tunakausha vitu mbalimbali. Samaki, sweet potato, cassava, hizi matunda zetu, na kwa hali ya usafi na hali ya haraka. Hiyo ndio kitu muhimu, hali ya usafi na hali ya haraka.
This scenario has offered an opportunity for Kenyan institutions to develop a technology package that can utilize the latest advances in solar-driven cooling.
The first partner from Germany is called Fraunhofer Institute of Solar Energy. The second partner from Germany is Innotech Engineering Company. Then in Kenya we have Kenya Marine and Fisheries Research Institute. Then also in Kenya we have Technology University of Mombasa, TUM, in collaboration with food scientists, also from Kenya Industrial Research and Development Institute, KIRDI.
The project provides post-harvest drying and cooling solutions to fisher folk dealing in milk fish farming and Kimarawali processing in Kwale County of the coastal region of Kenya.
So what we have here in the Solcooldry Project is a system that is producing ice, flake ice, using green energy. The fishermen now can now collect ice, go and bring fish which is fresh, therefore reducing post-harvest losses on the fresh cold value chain.
So with the production rate of 500 kilograms of ice per day, it means that we can supply most of the BMUs or the fishers who are around here.
On the dry value chain also, we have dryers which have got air circulation through them, and these dryers are also now proven to be very hygienic in the sense, and also they have a bigger capacity.
Most of the BMUs in Kenya are not served by electricity. So our first concern was, can we have a system that can be fully or wholly driven by solar power? And that is why this system was designed.
Kupata samaki sahi ukileta hapa utapata barafu. Samaki zina shida kidogo, unaweza pia ukasileta hapa kwa kukausha, kufanya ngonda, ili biashara iwe inaendelea mbele. Si kurudi nyuma kama vile mwanzo. Mwanzo tulikuwa tunaharibikiwa sana. Maana kuna tani na matani ya samaki ilikuwa zinaweza zikaharibika na ujui utafanya nini.
One component of drying is standalone, is what can be used by anyone outside there. Or it uses direct solar energy, which means it's a tunnel dryer. It has a tunnel dryer with a fan that is driven by solar power. So this dryer that we have here is fully protected. It's a canopy, 23 meters long, and it can work whether it is raining or not raining. And also it prevents the entry of vermins and flies into the system. So it ensures total hygienic drying of fish. Then we have a second dryer, which is, we call it an integrated solar tunnel dryer. Why integrated? It is integrated because it is supplied with the hot water system from the solar thermal collectors. This hot water is stored in a big tank, and this water now circulates in the solar dryer to ensure that it dries, or it undertakes drying 24 hours a day, day and night.
The outputs of these projects include a standalone solar drying cooling system, technology startup business plans, and a quality management system for the production of hygienic products for market access.
So TUM as a partner is coming in with the aspect of HACCP, that is hazard analysis, critical control points, because we know this system is going to process fish products. So we want to see during the processing stage, are there any stages or points which are critical so that we avoid hazards when this final product is out from the process.
The project is designed as a technology adaptation and transfer intervention that will target the two fish species for value addition and quality handling.
And then you can not only use it for the fish, you can use it for nearly any other commodity, and this gives you a good possibility or a good opportunity to increase the local livelihood.
The proposed project aims to reduce post-harvest losses and will provide fish in higher quantities and quality to the local and national consumers.
It's a chance to use the green energy, the photovoltaic and the solar thermal energy to do food processing and to preserve foods, to reduce the food losses, and in this way to support the local economy, to give especially also the young people, to give a future to them, and also to the women's.
Sasa hii ndio mnofu wetu, hii ndio mnofu wetu. Sasa unatakana uangalie ukishatengeneza.
Value-added dried fish will also improve the income of fisher folks. This will directly contribute to food security.
So the objective of this training is to train the mama karangas to know how to do value addition and make several products out of fish, which can be sold at good price and make profit out of their businesses.
Na tumeona ubora wa samaki kuwa ukimtengeneza zaidi unapata manufaa zaidi na kuboresha biashara yako kuwa na kipato kuliko ile samaki unayemkaranga.